focusing on the topic of integrated automation. So integrated automation is nothing but integrating the input and output devices through a controller. So the controller what we are using is PLC. In this panel we are having two PLCs, one is Delta PLC and another one is Siemens PLC. So we have drafted a program using the Delta PLC. So in this panel we are having a few major components like PLC, Delta PLC, Siemens and 8-channel relay board, SMPS and MCBs and a few sensors like thermocouple sensor and output device and proximity sensor and output device like VFD and traffic light and step-on motor and DC motor. Can anyone explain about relays?
So relay in the PLC act as a switch. In the condition in the PLC program is true, the relay activates. In the conditions the false, the relay turns off. Working, the PLC will receive the input, receive the program, check the condition. If the condition is satisfied, the relay turns on. For example, if we press the button, the PLC detects it, relay turns on, then motor start. Then the main function of the relay is used to control the high power devices and low power signals.
So in this, for education purpose we are using the relay, but in industrial grade we are using a contactors. Exactly the same as relay, the contactor which have more industrial grade and more reliability. So the major components is SMPS. Can anyone explain about it?
SMPS in PLC stands for switch mode power supply. In SMPS, the electrical power supply is used in the PLC to convert the electrical power into from one form to the another. The role of SMPS in PLC, it convert the AC main 230 into 110 volt into low power DC voltage 24 volt. It is stable and regulated the power supply of the PLC components like sensor, actuators, input and output, CPU module.
Okay. So we are going to see a program of how to control a traffic light by using some timers and counters. And so these are the program. The basic logic of the program is the ladder logic program through Delta PLC. So anyone explain about PLC? Yes.
PLC is a programmable logic controller. It's a special type of computer used to automate the machine process. It helps to
A little bit louder and slower.
It helps to control the equipment like motors, lights and all other switching process. Without any human interaction, a PLC works by taking inputs like sensors and actuators.
Okay, let's see about the ladder logic program. For Delta PLC, we are going to open the software called the ISP soft. So for connecting the sensors and the PLC, we have to open the COM-MGR. This is the communication protocol that will connect the output devices and the PLCs. So through the COM-MGR, we will be able to configure it. Through configuration, we are able to auto detect it. Through it, which will be automatically detect the communication between the PLCs and the input indicators. So this is the ladder logic program what we have designed for the traffic light controller. So that we are majorly using the concept of timers and counters. Can anyone explain about the timers and counters?
So, sir, coming about timers and counters, they are the essential instructions which is used in a ladder logic timer. So, it is used to control the time-based and event-based occurrences in the PLCs. So, coming up while timer, it is used to it will introduce a delay in a control process. So, when the event is start, the timer will run, sir. So when it touches the preset values, the instructions will be followed, sir. So there are three major types of timers, sir. On delay timer, off delay timer and retentive timer. So on delay timer is nothing but the timer will start after the delay on, sir. Off delay timer is the timer will start after the delay off. So retentive timer means both the functions will be done. So counters, it will count the number of event that occurs in a process. For example, if in a conveyor, sir, so the object will be passed, sir. So number of object it process it detects, sir. So number of project objects it will count, sir. So it is known as the counters. In that there are three types of counters, sir. Off, on counter, off counter, and on and off counter, sir. So that's all about the counters.
Okay. So we can see about the program. So firstly we are able to open the normally open as M1. The M1 is nothing but the memory variable that will be as a virtual basis. So we have to set the preset value to set mode. It has three conditions. One is output and set and reset. We have to set it. After setting, the M1 value will be directly goes to the output Y0. So then M1 will be automatically enable the timer of T0 to a 50 milliseconds. That is 5 seconds. After that, the T0 is set to the condition of reset condition to the virtual value M1. Then M1 will be automatically set for the next cycle, that is yellow line. That will be considered as the M2. Then M2 will be automatically to the output supply Y1. Then M2 will be enabled as the timer 2 for milliseconds of 50 milliseconds. Then the T1 value will be automatically reset and then to be set for the next upcoming input. Then M3, the virtual 3 value will be set to the third output Y2. Then the third output value will be enabled for 50 milliseconds. Then it has to be reset to the M3. After that, the M1 will be set for the loop cycle. Can we see the real application? For that, we have to compile it first. After compiling, we have to run the PLC. After running the PLC, we have to download the program and transfer the file to the PLC, from the software to the PLC through CommGR. That we have already preset the value. After that, we have to go to the online mode. When you are going to the online mode, we can able to see that green line is enabled all over the input or the output terminals. So we have to make the condition set on for the red light enabled or for a 50 time. The enabled bit P0 will be automatically enabled. Then the M2 will be enabled for the green light and the yellow light. Then it will be formed in a loop. So is there any doubt for it? Can we see next program in our next class? So thank you.